$40 billion in damages. 4 million barrels of oil spilled into the Gulf of Mexico. 11 workers killed. These are only a few of the consequences associated with the 2010 BP oil spill. The I-35 Mississippi River Bridge collapse led to $43 million in economic damages. 145 individuals were left injured, and 13 others killed. What makes these two events similar is that both events were caused by structural cement failures and the inability to monitor cement accurately and continuously. And thus, our technology is the solution. Dr. Vipu started developing smart cement back in 2012 with the value proposition that it could prevent future catastrophic events and save lives. And so with this vision in mind, Dr. Vipu earned $2.6 million of funding from the Department of Energy, in addition to $500,000 from Baker Hughes. Both of these funding opportunities were strictly for R&D technology. And so Dr. Vipu had approached us about a year ago, and thus Sensytec was born. Hello everyone, my name is Kevin Cho. This is one of my co-founders, Dylan Center, and today we will be telling you the story of how we've taken smart cement from the lab to the real world.
But before we get into that story, you're probably wondering what smart cement actually is. Basically, smart cement is a technology that gives cement sensing properties. It works by mixing in our proprietary conductive additive. Once this additive has been evenly dispersed, the cement is able to transmit data on its conditions. This data is received through a system of wires, which we've tested in our own 40-foot field well, and the prototyping, which you can see behind me. The data we receive is able to monitor things like pressures, cracks, damages, and even contamination, which users can take this information in order to prevent future cement failures. Now I understand if this sounds a little bit complicated, but trust me, it's actually very simple. You see, smart cement is a lot like your skin. If you were to poke your hand with a needle, your nervous system sends pain signals to your brain, letting you know that there's an issue. In a similar way, smart cement is able to detect any issues within the cement and send this to users so that they can react accordingly in real time. Now, when we heard of everything smart cement could do, our minds ran wild with all of the possibilities. We thought about bridges, roads, highways, dams, basically anything that involves cement. So we went out and started talking to cementing experts. One of these experts, who is now on our advisory board, is Ernest Cubitt, the former general manager at TXI, where he led his cementing division to over $1 billion in annual revenues. After meeting with several experts like Ernest and listening to them about which industry they thought needed our technology the most, we realized that we needed to narrow in and focus on one initial target market, and this market was oil and gas. This decision was our company's first pivot, and we came to it because we realized that oil well operators needed a much better way to monitor their well cement, especially after the BP oil spill. Now, with this assumption at hand, we knew that we needed to validate it, and it just so happened that about a week after our decision was the world's largest oil and gas conference, OTC, the Offshore Technology Conference. In an effort to stay lean, we attended OTC as students, which granted us not only free admission, but the ability to get essentially anybody to talk to us, and so we did. We spoke to more than 20 industry-leading companies, including Shell, Exxon, Halliburton, and Schlumberger. The purpose of these meetings was to determine how companies currently monitor their cement. What we learned was shocking. For companies to monitor cement on wells, they have to shut the well down completely, cease production, and incur costs of nearly $3 million annually per well. This helped us realize that our value proposition went beyond catastrophe prevention and saving lives. It now also included decreasing millions of dollars in cost and increasing efficiency. This information led us to our next hypothesis, which was that our first revenue stream would be to sell smart cement directly to the customers that extract oil, the BPs of the world.
After OTC, we set up meetings with both Exxon and BP to validate this hypothesis that they would actually be our customer segments. And so our approach was to learn more about the problems that we already knew that they had and to test the assumption that our smart cement system in its current state could solve these issues. And so both of the companies told us that after beta testing, they would be potential customers for sure. But that's when we started getting into our first roadblock. So as soon as we started getting into the wiring system needed to extract data out of our system, both companies stated that it would be impossible to implement the system in an actual offshore oil well. And so this would lead to one of our most crucial pivots. We essentially had to change our entire technology system. And so to deal with this whole issue, Exxon had recommended that we talk to some of the companies that actually build the oil wells. And these companies are called oil and gas service companies. So we ended up getting a meeting with one of the biggest players in the industry, Baker Hughes, who has a 20% market share within the industry. And this meeting consisted of their team of director, business manager, and lead technician for cementing. And so within this meeting, they agreed to partner with us to solve this wiring issue. And now we are proud to say that we have a solution. Today we have developed a wireless method. Lab testing has been very successful, and we plan to implement large-scale testing within the next 3 to 6 months. Now, just to be clear, we didn't just talk about technology within this meeting with Baker Hughes, but we also learned the whole process of building wells in general. And so what we learned was that we couldn't just directly sell to our customer segment, the oil operators. Rather, we would reach them through the oil and gas service providers. Like I had mentioned, they are the companies that actually build the oil wells. And so it was clear that we needed to pivot our business model, and thus, Baker Hughes would be our distribution channel to supply our customer segment. And so just to be clear, our model is to supply smart cement additive to Baker Hughes, and then Baker Hughes will supply the smart cement system to their clients, including installation. And so it would be clear that Baker Hughes would be one of our most important key partners. Now, at this point, we very naively thought that.
Slide.
Yes. Sure. Oh. Yes.
Right.
Okay, thank you. So we naively thought that our business model was perfect, but that is until we realized that there was a new revenue stream that we can discover. And so we had this discovery in a meeting when we were with a board of advisors from oil and gas companies. And so we were explaining our technology, and several companies had asked the question if there was some sort of software that could read and analyze data from our smart cement system. And so once we realized that this was a need, we found an opportunity to expand our potential revenue streams.
So, in an effort to continue on with Lean Model Canvas, we scheduled follow-up meetings with these companies to determine if there really was a need for this software. Our goal in this meeting was to analyze how companies currently interpreted the data that they received. And it turns out that they have to bring in outside strategic consultants to analyze and interpret the data for them. If our software is developed correctly, it can potentially cut out the need for many of those software consultants, further enhancing our value proposition of decreased costs. This made it clear to us that we needed to develop the software, and so we decided to do that, and this was a critical pivot in our business model. Baker Hughes, though, has luckily agreed that they will let us follow up with the clients that they sell Smart Cement to, so that we can then sell them the software license they will need. Ultimately, this means that we will need to implement a sales force into Sensytec, which will allow us to sell that software license and manage our customer relationships. This all leads us to our current Lean Model Canvas, where we've decided to do a bottoms-up analysis of our market. Now, although our total global market is the cementing market, which is $450 billion, our initial market size for offshore well cementing is nearly $1 billion. This market size is split into our two revenue streams, as well as our cost structure. You'll see that for additives, the majority of our costs are incurred through purchasing of raw materials. And for the software, the majority of our costs go towards software development. With these anticipated costs at hand, we're putting a major emphasis on fundraising so that we can purchase the key resources we need to further this business. These resources include, as mentioned, purchasing raw materials, software development, patent costs, and much more.
The reason why it is so important for us to obtain these key resources now is because we are in conversation with Baker Hughes about the timeline of Smart Cement's release. They have projected that Smart Cement will hit the market in Q2 of 2017. In addition, we have received a letter of intent for their first year minimum order quantity of 3,600 pounds of additive. And so clearly, Baker Hughes is a very important key partner to us. However, we're very open to getting partnerships within different industries we plan to pursue in the future. For example, we have been working with the Texas Department of Transportation and one of their highway construction projects. Also, we have been in communication with the Department of Energy to further our partnership with them. These are two examples of key partners that we intend to further our partnership with them. And so, with that being said, thank you very much for listening to our story. Our goal is to make cement smarter, to make the world safer. We are Sensytec. Thank you.
Thank you.
Okay, I heard a lot lot of interesting information for me. I'm not familiar with this industry, but sounds very fascinating. What are you planning to patent? I mean,
sorry.
what are you planning to patent? Where is this
So the patent
core
covers.
of your innovation?
Right, sure. So the patent covers the additive, our proprietary additive, in addition to the dispersion process in which we apply the additive to the liquid cement so that the cement can be sensing.
As well as in regards to our software, we're going to be developing that in-house, and so our software, that code will be proprietary to us.
So software will be proprietary, and what is it, ingredients of
Yes.
this smart patent?
The additive ingredients.
Right.
Help me to understand the relationship between the original professor that was developing this and your company today.
So our inventor is Dr. Biku, and he is an inventor from the University of Houston. He had approached, we go to the Wolf Center for Entrepreneurship at UH, and so he had approached our program to get help in commercializing this technology. And so we had,
I'm going to cut you short.
Yes.
Is he an owner in the company? Is he licensing it? What's the relationship
Said it's
between the
easy
professor?
technology.
Yeah.
He's licensing the technology.
He's licensing it, and that's a pre-established license that's in existence, and is it exclusive?
The license is currently in negotiation. What I
Okay.
can say is that it is exclusive.
Okay.
All fields and global.
Okay.
In regards to like other issues, those parts are still being negotiated.
So
Okay.
he owns it. He owns the technology, right?
Yeah. Yes. Yeah. The
So,
patent.
Or the university.
who owns the patent?
The
University?
university. The patent.
Okay.
Yeah, got it.
And how long ago it was issued? How long ago it was issued?
The patent?
yeah.
our provisional patent was filed as of July of last year, and so our non-provisional will be finished by the July this year,
So recent.
or file.
You put a number up there that said that you might be able to measure a well without having it stop. You'd said $3 million. Is that $3 million per well?
Yeah, so to explain that number, right now it currently costs about $1.5 million each time they want to do cement monitoring. They
Yeah.
do that roughly twice a year on every single well.
Got it. Okay, so does your system currently, do you project that it's going to allow you to monitor the cement without shutting down the well?
Absolutely. The
Okay.
key advantage to a few of the advantages
Yeah.
to our technology, and nobody else is doing it right now, is that it monitors in real time,
Yeah.
so it's continuous. Because it's a part of the cement,
Yeah.
they don't actually have to shut down the well. We just
Yeah.
have to connect to the well so that that data is constantly transmitting to a computer where our software then analyzes it.
And then the short version of where you're actually monetizing it is in the additive and in the software?
Yes.
Yeah, so for the additive, just to give you an idea,
Okay.
the additive, our pricing right now is about $25 a pound. That's
Uh-huh.
120% profit margin.
Uh-huh.
For the software, we're currently testing pricing because, again, right now that product is under development. We're testing pricing. We're looking at pricing based on how much companies currently spend on well maintenance every year, which
Uh-huh.
the average offshore oil well spends about $200 million on
Two-
offshore maintenance.
Will they be able to? Will they be able to stop shutting down the well? Will they save $3 million per well by using your technology, or will they still have to shut it
No,
down?
They first for measuring cement, for monitoring
Yeah.
cement, that test they wouldn't have to shut down the well.
But they're still shutting it down for other stuff?
At different tests.
Okay, a different test. Okay.
Yeah, so
okay,
we
gotcha.
would be saving
Okay.
them that $3 million. We save them that, yes.
Have you considered pricing it as a percentage of the savings instead of 20 whatever, how many dollars per bag of cement?
That's a great question. So in the additive, right, as mentioned, if it is only $25 per pound, that is a small part. That is the smaller part
Right.
of our revenue stream. And so
Right.
one idea that we have also had is maybe letting users implement Smart Cement, the additive, for free,
Uh-huh.
and then following up with the software because that's where the majority of our revenue is. That way
Because
we
they
get
can't
into
do
the
anything
wells.
without it, right?
Right.
Exactly.
Yeah.
I mean, you give away as much additive as you want, but you're the only ones that can read it.
Mhm.
Do you have a slide of your business model so that we understand what actually you're trying to do with the company?
So there's this one.
Yeah, use that one. You wanna come?
So just to be clear, we give the additive to Baker Hughes, and then Baker Hughes will then use its smart cement additive to build the smart cement oil wells for the clients.
For
So-
everybody in the industry, right?
Yes, for all of Baker Hughes' clients. And so Baker Hughes, within our strategic partnership, has allowed us to follow up with all their clients who get smart cement in their oil wells, and we can offer them a license to our software.
One thing I want to make a little bit more clear is how cement is used in wells, because I think there might be confusion there. Basically, when they build a well, they drill this big hole, and they put a pipe down that hole that's where they extract the oil. It comes up through that pipe. But the problem is there's gaps between the ground around the hole and the pipe. So they they pump cement down through that pipe to fill up the area to secure it. That's where the issues occur. For example, in something like the BP oil spill, if any air bubbles get into that cement, it creates leaks, which ultimately can create explosions like that. And with our cement, you would know if there's air bubbles, you would know if there's a crack, if there's pressure going onto the cement, you'll know that. If there's contamination from soils, it can detect all of those things.
And why did that professor choose you? What did you offer him?
So essentially, what I can tell you is that within our education, the Wolf Center of Entrepreneurs is one of the top schools, entrepreneurship school in the nation. And so he trusted that our brand would solidify.
So it's not your company, it's the entrepreneurial center that made it deal.
Okay, so Sensytec is 100% our company, yes. We are the students who founded this company. We own all of the company. The license negotiation is under terms, but that percentage equity is actually very small. Beyond that, we own 100% of the company. To further elaborate on what he said, we've spent the past year building this company, and we competed in our university business plan competition, which we won. And so that really validated us to the inventor, and that's why he's letting us license it at this point.
There was a pivot that you talked about that I didn't understand. At one point, you said you had a problem and you went to some type of wireless technology. Really quickly, can you explain the difference there? Because I didn't understand what that pivot was about.
So we're going to pull up a picture. You're going to see, this is our current prototype.
Yeah.
It's this wired well. Okay, so this
Okay,
is
so
the
you're attaching wires to the cement.
That was the
Got
previous
it.
system of how we extracted
Got
data.
it.
That can't work in a 10,000 foot, 30,000 foot well because you can only imagine how many wires you would need.
I've got it.
The current system that we have is wireless.
Oh, the wires were going all the way down.
The wires would
different
have to go
locations.
down.
Okay.
Because one key
Okay.
factor is that our technology can it can let you know that there's a crack at this depth. And to
Okay.
do that, it needed wires placed throughout so that it
Okay.
could do that. With the wireless system, we can still achieve that, but now we don't need those.
Where is your data center?
Okay, so actually
Where do you aggregate all the information?
for the way that the data works is that, so this is one thing that's going to have to be discussed in contracts that we have with clients. We have a contract lawyer that we're working with right now to determine this, but under our current assumptions, oil well operators won't let you own their data,
No, they
and so
won't.
the data will go directly to them. Our software, we don't need to own the data, but we're going to analyze it for them so that, it's a very complex process to
How can
actually
you
look at.
analyze it if you don't have access to it?
The software would be built, the data goes straight into their software, and it's built to analyze it from there. We don't have to receive it to analyze it. The software would do it
Oh.
automatically.
You mentioned about your partnership with a company called Baker Hughes.
Yes.
What kind of partnership? Because it seems like you are heavily depending on that channel. I mean, if they don't want to work with you, I mean, there is no other options.
So I think what you're alluding to is perhaps our business model is too hinged on this company for our success. If they weren't in the picture, then we wouldn't be able to.
You won't be able to do that.
However, what I can tell you is that our partnership with Baker Hughes is we trust in it because they have invested back in 2012, as we had mentioned in the presentation, $500,000 to technology, and also their goal with partnering with us is to be an industry leader. And so with this technology, they will be the first to have real-time monitoring.
But can you understand help me to understand what the partnership is?
Okay.
A strategic partner, the equity partner, I mean, what kind of partner? I mean,
They
what
are
do
a
you do?
strategic partner, no equity in the company. As you mentioned, they're doing this to gain that level of industry excellence where they can say that they are the best in the cementing industry. Beyond that, as we had also mentioned, we do have a letter of intent for our first year of order quantities, pending the beta testing that we're going to do in Q1. So we do have that, and those contracts are actually in the process right now. Those are with our lawyer, and so at this point, the partnership looks very promising.
If oil and gas is first, what are your second and third industries you're going to target?
Our second industry, as we mentioned, is that we're working with the Department of Transportation in Texas on a highway construction partnership. So our second industry, I would say, is probably transportation, things like highways and bridges. I'd like to paint a picture of why this is very important. To note, in California, right, if we were partnered with the California Department of Transportation, they built all the roads and bridges and things like that with smart cement, and then an earthquake occurred along San Andreas Fault. Currently, they would have to go out and check everything to see if there's any issues. With our technology, they would with our technology they would essentially be able to just look at a computer screen and know every crack in the city.
Thank you very much.
Thank you.